So this video, we've already done one just kind of quick video going over some of the features of like how you can graph on a calculator, how you can adjust your window, how you can play around with the table of values. I want to do a similar video here, but I want to look specifically at systems of equations. So we talked about this in class, like how you graph a system of equations. And remember, when you're graphing a system of equations, you can certainly graph it by hand. You definitely would want like graph paper, because it's very precise. But even then, depending on your solution, like if your solution had decimals or fraction values, graphing by hand is not the most ideal way to solve a system of equations. Now, if you have a graphing utility like a website like Desmos, or if you have a graphing calculator, graphing a system of equations is a great way to get a solution. Okay, so that's what I want to look at in this video. So I will bounce between the whiteboard and the graphing calculator a little bit. So first, let's go to the graphing calculator. Here we are. Okay, so I have this up from the previous video. So if I were going to start typing in my system of equations, first thing I would want to do is go to the y equals button. Now, sometimes if you turn on your calculator and you see a weird screen, you're like, oh my God, you know, no big deal. It's very easy to get back to that just basic home screen. All you have to do is go second mode. If you look above the mode button, it says quit. So if you hit second mode, it quits whatever screen you're on and it takes you back to the home screen. So always remember that. But for us, we want to go to y equals. We need to type in a system of equations. Now, there's already an equation in there from the previous video. You want to clear out the old junk, okay? It just makes life easier. I like to just clear out anything I'm not using. Sometimes it can really complicate things, so sometimes you have to clear out old junk, but just clear it out, okay? Now, for me, I clear everything out. I always put my two equations in y1 and y2. Now, here's the thing. This literally says y1 equals and y2 equals. That means the two equations in your system have to be in slope-intercept form. You have to solve them for y before you can type them in, okay? So let's go to the whiteboard now. So if I go to the whiteboard, let's say we have the following system. So I do have a stylus. I'm on my laptop. It's maybe not the best setup, but we'll manage, okay? So let's say for my first system, I have y equals 3x minus 4, and then I have 2x plus y equals 1. I kind of feel like we did one similar to this in class. It may not have been the exact same system, but it was similar. So the first equation is good to go. I can type that in. It's already in the form y equals. It's the second equation that I need to work on. So I have 2x plus y equals 1. I need to get y by itself. The issue is this plus 2. The way I move the plus 2 is by subtraction. So 2x minus 2x is 0. 0 plus y is y. Y equals negative 2x plus 1. So my system is now, the first equation, nothing changes, 3x minus 4. So maybe write this on paper because I'm going to switch over to the calculator in a second. And the second equation, when we solve it for y, it is negative 2x plus 1. Okay, so I am going to write this down so I can go to the calculators. Y equals negative 2x plus 1. Okay, so take a second, pause the video if you need to, write these down, and then we're going to go to the calculator. Okay, so going to the calculator, I already have it on my y equals screen. Okay, and that's the very first button on the calculator over here, y equals. Okay, and I want to type in the two equations. I do not have to type in the y equals. That's already here. I just need to type in the right-hand side of the equation. So the first equation is y equals 3x minus 4. I need to type in 3x minus 4. So I start with just a regular 3, no big deal. The variable, hopefully you remember from the previous video, look for the two colorful buttons. Look for the one that says alpha. Beside alpha, directly to the right of that, is a button that says x, t, theta, and n. That's the button we want to use. So that's our x. And then we need minus 4. Now, you always have to be careful with your negative and your minus. They're actually two different buttons here. If you're just doing regular subtraction, do the regular subtraction button. If we're talking about like a negative value, like if we had negative 3x instead of just positive 3x, then we would use the negative button. I'll try to make sure we have an example of that in just a bit, okay? So for us, just regular minus button, minus 4. Now we want to type in a second equation. So I'm just going to hit this down arrow, this little circle of buttons. Those are your like directional buttons. So they go up, down, left, right. We want to go down. And now I want to type in the second equation, which was negative 2x plus 1. So this situation, we don't want the minus button, we want the negative button. So the negative button is down here. It's the very last row of buttons, and it's the second to last. It's beside enter. So that is a little bit different than your minus button. And you can tell when you type them, the negative button is shorter. The minus button is like a longer dash, okay? So anyway, we want negative 2x plus 1. So I'm going to do the negative and then 2, and then back to that green alpha button. Directly to the right of that is xt theta n. That's my variable. And then I want to go plus 1. So there are my two equations. And the first thing I need to do is look at the graph of them. So this calculator graphs them automatically, which is amazing. Okay. And there you have it. So that is your system of equations, right? What we're looking for is where these two lines intersect. Visually, we can see it. It looks like it's right here at 1, negative 1, but we want to verify that it is at exactly positive 1, negative 1, my ordered pair, x being 1, y being negative 1. And our calculator will calculate this for us. So a really common button sequence that you'll use is second trace. So if you go to this first row of buttons, the fourth button is trace. If you look above it in blue, it says calc. That button will calculate certain things for you. For example, it will calculate our intersection here. So to get to that calc screen, you want to hit the blue second button and then trace, and it'll pull up that hidden feature of that button. Now, here you have these 7 options. The one that we're interested in is option 5. We want to know where these two lines intersect, right? So we choose option 5, and then it's going to ask you a few questions. The first question is going to be like, hey, is the cursor on the first curve? It will automatically be on the first curve. The way you say yes is you just hit enter. It's going to be like, okay, did we move a cursor to the second curve? You're going to again say yes. It automatically just bounces a new cursor to the second curve, hit enter. And then it's going to be like, should we guess what the intersection is? Say yes. And here you have it. So we could see visually that it looked like it was at the ordered pair 1, negative 1. Now we have the calculator backing us up. If we were going to try to freehand this, we would have to be super duper precise. We even did an example in class where, you know, the graph was a little wobbly because I'm graphing it this big and it looked like our solution was going to be like 2, 2, but in reality, the actual solution was like 6, 11. Okay. So you want to be really careful when you're solving systems of equations by graphing. It's always best to back up whatever you graph on paper with a calculator or some kind of website that does graphing for you. So if we go back to the whiteboard, we can say with confidence that the solution here is, 1, negative 1. And if you want to, remember, you can check your work, okay? So if we wanted to, remember, the original system was y equals 3x minus 4 and 2x plus y equals 1. We can check the ordered pair 1, negative 1. Remember, we did this in class. So what you do is you plug in the x and the y value into both equations. And if both equations are true, you know that that's the solution. So if we look at the first equation, we would get negative 1 equals 3 times positive 1 minus 4. So I get negative 1 equals 3 minus 4. Well, 3 minus 4 is negative 1. So everything works for the first equation. We would now just do the same thing for the second equation. So I get 2x, but x is 1, plus y, which is negative 1, equals 1. So what I really get is 2 minus 1 equals 1. Well, what is 2 minus 1? It's 1. So this ordered pair satisfies both equations, therefore it's definitely the solution, okay? Now, a couple of weird things can come up when you're graphing systems. So let's go, well, let me just do this on the whiteboard first, okay? So we're gonna, this comes up in the section on systems of equations. So depending on if you've watched that video or not, this may or may not make sense, but there are special types of equations or special types of systems that have either no solution or they have infinitely many solutions. So they don't have just that one single ordered pair that satisfies the equation. So let's look kind of quickly at both of those. So let's say we had the system 6x plus 2y is 7, and then y equals 2 minus 3x. Okay, so the first equation is fine. It's in slope-intercept. Well, it's in slope-intercept form. The second equation, we need to solve it for y so we can type it into the calculator. So I get 6x plus 2y equals 7. I want to get the 2y alone, so I'm going to subtract 6x from both sides. All right, so I'm going to kind of move this up here just for the sake of space. So now I have 2y equals negative 6x plus 7. I want to divide everything by 2. So I get y equals negative 3x plus 7 divided by 2. You could just keep it as a fraction, or you could put it as 3.5. It doesn't matter. Okay, so you've got those two equations right there. Okay, and I'm just going to, for the sake of space and just time, I'm going to put a square around them. Those are our two equations. So let me write down the second one really quick. So I've got y equals negative 3x plus 3.5. That's the first equation. The second equation in the system was y equals 2 minus 3x. Okay, so pause this video for a second, and the two equations in boxes, write them down. Okay, so I'm going to go back to the calculator. I'm going to go to y equals. I want to clear out the old system. I don't want it there anymore. So I'm going to hit clear. That clears out the first equation. Hit the down arrow, hit clear. Clears out the second equation, and then I'm going to go back to y1. So y1 is y equals negative 3x. So the negative button beside enter, the 3, and then that xt theta n, and it was plus 3.5. The second equation was 2 minus 3x. So I'm going to do 2 minus 3x. Okay, and if you look at these carefully, like let's say instead of doing 2 minus 3x, let's say I did negative 3x plus 2. Hold on, I forgot my x. This is the same thing. I've just rearranged the terms. Nothing crazy happened. But if you look here, we have the same slope. So remember, in slope-intercept form, the coefficient of x is the same slope. So these two lines have the same slope. They cross the y-axis at different places, okay? So let's look at that graphically. So you can see these two lines, they're pretty close to each other, but they never intersect, okay? And we could expand this graph out forever. We could go to the window if you wanted to. And let's say we did negative 100 to 100 for the x-axis. Let's say we do the same thing for the y-axis, negative 100 to 100. So we're going to zoom way out, okay? And you can see it's hard to tell here, but those two lines still don't intersect. They're really, really close to each other, but they don't intersect. So what's happened here is we actually have two parallel lines. And if two lines are parallel, that means they never intersect. So if two lines never intersect, they don't have a point of intersection. So let's see what happens if we try to get the calculator to calculate that for us. So remember, we want to go to the calc screen. To get there, we go second trace. So second trace, I want to go to intersect. So it's going to say, hey, am I on the first curve? Yep. So hit enter. Hey, am I on the second curve? Yep. Hit enter. Do you want me to guess? And oh no, you get an error. Okay, so that's telling you that these two lines don't intersect. Okay, so if you have two lines that appear to be parallel, you can double check it two ways. You can try to find the point of intersection on your calculator, or go back to those two equations. Okay, if we go back to the two equations again, those two lines had the same slopes. They cross the y-axis at different places. Okay, so that's an indicator that you've got parallel lines. Same slope, different y-intercepts. Those two lines are definitely parallel. They never intersect. They have no solution. Okay, I do want to show you that. And then one other thing, let's go back to the whiteboard. So there's a second type of system where like every point on the lines intersects. Okay, so let's say that we have 4x minus 2y equals 2. And 2x minus y equals 1. Both equations need to be solved for y, and you'll notice something when we solve these equations for y. You'll notice it right off, but we're going to do the whole process. So let's say for the first equation, we have 4x minus 2y is 2. I want to get the 2y alone, so I'm going to subtract 4x. That gives me negative 2y equals negative 4x plus 2. Okay. I divide everything by negative 2. And just for the sake of space on my screen, I'm going to move the simplified version up here. So -2 divided by -2 is 1. That gives me my y. -4 divided by -2 is +2. So I get +2x. And then +2 divided by -2 is -1. Okay. So that's the first equation, solve for y. Second equation, my stomach is growling. If you can hear it, please ignore it. Okay. Second equation, we want to subtract the 2x. So I get -y equals -2x plus 1. Divide everything by -1. So you're going to get some sign changes. That'll give us -1 divided by -1 is +1y. -2 divided by -1 is 2x. And then +1 divided by -1 is -1. What do you notice about these two equations? They're exactly the same. So we have these two equations that actually graph the same line, and you can see that when we go to the graph. So let me write down 2x minus 1. So pause that if you need to see. All right, we're going to go back to the calculator. I'm going to clear out the old junk. That's just what I do. Instead of typing over it, I just get rid of it. All right, so I want to type in 2x minus 1. So 2x minus 1. And then the second equation, even though the original system, it looked like you had two different equations, they're actually the same thing. So you get 2x minus 1. Let's graph. So you could see really quickly that it graphed a blue line and then immediately graphed a red line. Okay, so you had to be quick. You had to notice it like right off the bat. But like, let's say we do this. Let me see if I can. All right, so pay close attention. It's like a magic trick. It's going to do a really quick blue line, then a really quick red line. Okay, so you can see right there, those two equations graph the same daggone line, right? So they're going to intersect everywhere. All right, so if you do the second trace and then intersect, it's going to do the same thing. Are you on the first curve? Sure. Are we on the second curve? Sure. What's our guess? Intersection. They're going to give you one single point of intersection, but just know that's only one of infinitely many solutions. So be really careful. Okay. If you have two equations that graph the same line, that is one of the solutions, but there are actually infinitely many solutions. So every single point on the line, those two lines touch. So every single point on the line is a solution. Okay. So I think that's about it. That's kind of showing you some of the calculator features. I'll try to make these videos as graphing stuff comes up. Okay. It'll kind of be dependent on time, but there you have it. So hopefully these help. All right. Take care.